All right, let's get started. Today, we're going to cut through all the noise, all the hype around AI assistants to talk about something that actually matters in the real world: sovereign control. We're going to break down the engineering reality of what it takes to implement GitLab Duo in a secure, maybe even an air-gapped environment. Look, this isn't about AI magic. This is about control, and it's about avoiding the kind of disasters, the footguns, that we see all the time.
Welcome to Debrief. We dissect the challenge of scaling collective intelligence, identifying the building blocks to translate greenfield concepts into executable sovereign roadmaps. From vibroffling to self-improving air-gapped feedback loops, we are here to help ensure quality of outcomes. Because in this industry, there are no silver bullets, only a progression of identifying footguns.
So here's how we're going to tackle this. First, we'll talk about the why, the whole sovereign AI imperative. Then we'll get into the landscape of GitLab Duo itself. After that, we'll dive deep into architecting for control, followed by the actual playbook for self-hosting, and we'll wrap it all up by talking about how to build a real feedback loop.
Okay, let's just frame the core problem here. All the hype says AI is going to make developers, 10 times faster. And sure, early data shows some big productivity gains. But here's the paradox nobody talks about. Writing brand new code, that's what, 20% of a developer's job tops? So if you only speed up that one little part, you're not a hero. You've just created a massive downstream traffic jam of code reviews, security scans, and compliance nightmares. The real goal has to be accelerating the entire lifecycle, not just the fun part.
And this right here, this is the whole game for any serious enterprise or government agency. The hard part isn't getting your hands on an AI tool. They're everywhere. The problem is plugging it into your systems without stepping on a dozen landmines. Data leaks, regulatory failures, your IP walking out the door. It's all about avoiding those footguns, not just chasing the next shiny object.
So, with that rather serious frame in mind, let's get into the tool itself. I'm going to hand it over to our engineer to break down the landscape for us. What are we really looking at when we talk about GitLab Duo?
Right. So, first thing to get your head around is that GitLab Duo isn't just one thing. It's a whole spectrum of tools. And as you can see, there's a really clear dividing line. You've got your cloud-first options, Pro, Enterprise, the Amazon Q thing, and they're all built for speed and convenience. But for the kind of environments we're talking about today, the ones that are highly regulated, air-gapped, the only path that's even on the table is Duo self-hosted. This is that fork in the road where control becomes everything.
And that choice immediately brings you to the single most critical decision you're going to make in this whole process. Once you say yes to self-hosting, you have to pick one of two fundamental architectural paths. And believe me, this choice decides everything: where your data goes, who touches it, and who is ultimately in control.
This really lays out the core trade-off, doesn't it? The default path, the easy button, is using GitLab's own AI gateway. It's way less work to manage, but your prompts, your code snippets, all of it gets sent out to external vendors. For a lot of organizations, that's an immediate non-starter. The other path, the self-hosted gateway, means you own the entire stack. Yeah, it's more work, but it gives you absolute data sovereignty. There's just no ambiguity.
Okay, let's just trace the data path here for a second. Your user, on your self-managed instance, makes a request. That request immediately leaves your environment. It hits GitLab's external gateway, then gets passed along to some third-party AI vendor, and then, finally, the response travels all the way back. Every single one of those arrows that points outside your little box is a conversation you have to have with your security team.
Now, look at this. It's a completely different story. The request goes from your GitLab instance to your AI gateway to your model and right back. Nothing leaves the building. The entire loop is sealed inside your perimeter. This is it. This is the blueprint for real air-gapped sovereign AI.
Okay, so we've picked the sovereign path. We've seen the pretty diagrams. Now let's get down to the engineering reality. What does it actually take to stand this thing up? And more importantly, avoid the pitfalls that turn these kinds of projects into expensive failures.
Before you even think about GPUs, there's a whole checklist of non-negotiables. You got to be on a modern version of GitLab. You need a very specific type of activation code, no legacy stuff, and composite identity has to be switched on. Then you need to get your network team involved for firewall rules and to make sure WebSocket Secure is supported. You get any one of these wrong, and the whole thing just doesn't work, period. And here is the sobering reality of the hardware. This is not a software-only solution, folks. Running these models requires serious iron. Even a smaller 7 billion parameter model needs a beast like an A100 GPU. You want to run the big Mixtral models? You're looking at a rig with 8 GPUs. This isn't just a feature on a slide. This is the price of admission for data sovereignty. And that hardware choice you make,
It completely depends on which of these models you're actually planning to run. And this is where the strategy comes roaring back in. It's not about just grabbing the biggest, baddest model on the list. I mean, look at this table. There are real trade-offs. Llama 3 might be pretty good for some code tasks, but its chat functionality is limited. You have to be incredibly deliberate and match the model to the actual business case. If you don't, you're just burning incredibly expensive GPU cycles for absolutely nothing.
All right, let's pivot to our final section, because this is where we connect all this engineering work back to the big picture. We've talked a lot about implementation, about the how. Now let's talk about genuine optimization, about the so what. It's just not enough to get the system up and running. The real value, the actual intelligence, comes from what you do next.
And this is the central question for every single leader listening right now. You've spent the capital, your team has configured the network, they've deployed the models, you have total, complete, sovereign control. Congratulations. Now what? How do you make this very expensive new capability actually intelligent in the context of your organization?
The philosophy you have to adopt here is mistrust and verify. You can't just plug this thing in and blindly trust what it spits out. The goal isn't just to have a generic AI assistant. The goal is to use this feedback loop like it's sandpaper, iteratively shaping and molding the AI until it fits the unique contours of how your organization actually works.
So what does that first turn of the sandpaper actually look like? Well, it starts right here in the admin UI. It's really just a four-step process. First, you register your self-hosted model. Give it a name, point to its endpoint. Then, and this is the most important part, you go to the AI Features tab and you explicitly assign that specific model to a specific task. You are the one who decides, okay, our Mistral model will handle explain code, while maybe some other model is better for generating tests.
And that simple administrative click, that is where you start capturing decision logic. That's the whole secret. You're no longer just using a generic AI. You are actively curating it. You're building a system that slowly learns and starts to reflect your organization's unique needs and patterns over time. This is the very first critical step toward creating a truly custom, evolving AI capability.
So we'll leave you with this thought. The technology to build a sovereign, air-gapped AI is here. The playbook, as we've laid out, it exists. But the tool is just the starting point. The real question is this: does your organization have the engineering and operational discipline to build and maintain the feedback loops that transform a powerful tool into a genuine source of scalable, collective intelligence? Because that's the real challenge.